Alright, so here we go with the exponential function integration. And again, we're just dealing with e. In future lessons, we will go over other exponential functions where we have different bases other than e. But for now, we're just looking at e. So here we go. Just like the derivative of e to the x is e to the x, the integral of e to the x is e to the x, but then we have the constant being added on at the end there. And if we do some sort of u substitution, we will also remember that we need to use our u substitution in there, basically the integration form of chain rule. So let's just go through some examples here. We're going to do some indefinite integrals that have no numbers on the integral symbol. We have no lower and upper bound, and then we'll do some other ones. So when we're doing this here, the first thing we're going to do is we're going to say u substitution here. U is equal to 3x plus 1. And du is 3 dx. I don't have a 3 dx here, so I'm going to move that over, make it a 1/3 du equals dx. So now I have the integral of e to the u times 1/3 du, right? Because I know that dx is equal to 1/3 du. Factor out the 1/3. The integral of e to the u is e to the u plus a constant. And the last thing we want to do is replace that u with what it is equal to. So 1/3 e raised to the 3x plus 1. And we got a plus constant out at the end. There is your final answer. Okay, and I want to encourage you to stop, pause the video, try these on your own, and then check back and see how you did with them. So I would encourage you to do that on each of these problems. As soon as I flip the page to a new problem, pause it, try the problem, and then check your answer. So again, we have e to the negative x squared. I'm going to say that u is equal to negative x squared. Okay, because I can start this off by factoring the 5 out. Okay, I can say 5 integral of x e to the negative x squared dx. Right, we could take any constants out there. Du is then equal to negative 2x dx. I don't have a negative 2, so I can take that over to the other side, negative 1/2 du. Oops, not dx, du, sorry. Du equals x dx. Okay, I have x dx right here. I have x dx, so that can be replaced. So I got 5 integral of e to the u times negative 1/2 du. I'm going to go ahead and take my negative 1/2 out front, so negative 5/2. The integral of e to the u is e to the u plus the constant. So finally, the last thing that I want to do is change that u back into what I set it equal to, which was negative x squared plus the constant. There's your final answer for that problem. Alright, so the next one here, again, we want to look and see, do we have an integral in this? So hopefully you recognize by now that if I have 1 over x, when I take the derivative of that, I end up with negative 1 over x squared dx. Okay, so hopefully you recognize that by now, but if not, there it is. I have the 1 over x squared. I don't have the negative, so I'm going to take the negative over to the other side and make that a positive. So this would be negative integral of e to the u. Like I said, we have 1 over x squared dx, so this would just be du. We just had to take the negative out there. So negative e to the u plus the constant. So negative e and u was 1 over x. Again, plus the constant. Make sure the plus c is outside. You don't want to make that part of your exponent. That does need to be after the exponential function there. Alright, I believe this is the last indefinite integral, and then we will do a couple of definite integrals where we use the fundamental theorem of calculus. So what do we notice the derivative here. So I'm going to say u is equal to cosine x. Oops, I don't want a dx there yet. So take the derivative, so du is equal to negative sine x dx. And again, we got to get that sine over to the other side, so I want to multiply both sides by -1. That gives me a negative integral e to the u du. So negative e to the u plus c. And finish it out, negative e raised to cosine x with a plus c out of the exponent. There you go, final answer. And again, you can always take the derivative of these and make sure that you get what you started with. We should end up with this right here if we take the derivative of that. Okay, so that's one way you can always check your answer. All right, so like I said, a couple of definite integrals here. E to the negative x dx. You could use u substitution. Eventually, hopefully, you'll get to the point where this is not necessary, because you're just ending up with du equals negative dx. So we just know we have to have a negative sign there. So integral from 0 to 1. Take the negative out front. E to the u du. We do have the option of plugging in our negatives there if you wanted to, or I'm sorry, not our negatives, our bounds into the x and change the bounds and leave it in terms of u, but I'm just going to replace it here. I'm going to say negative e to the u. I don't need a plus c. Evaluate this from 0 to 1. Replace the u, so negative e to the negative x. Evaluated from 0 to 1. Let's plug it in and see what we get. So I have negative e raised to the negative 1 minus negative e raised to the negative 0. Okay, double negative here, change that to positive. So I have, this is negative 1 over e plus e to the 0 is 1. So you could leave your answer like that, or you could say negative 1 over e plus e over e. So e minus 1 over e, whatever, it doesn't really matter. They're all the same thing. I don't know, you'd probably maybe see your answer written like that, but you might see it like this on the AP test. I don't know. They're both the same thing. Next. All right, so what do we do here? Do we recognize something that has its derivative? Well, I know the derivative of e to the x is e to the x. So if there is something more complicated that will give us that, we want to do that way. So hopefully, and maybe you don't recognize it, maybe you do, but do you see that if I take the derivative of, if I set u equal to this, then when I do the derivative of 1 is 0, the derivative of e to the x is e to the x dx, and I have e to the x dx right here. Okay, so this is the same thing as the integral from 0 to 1 of 1 over u du. What is the integral of 1 over u? Well, that's just ln, absolute value of u, evaluated from 0 to 1. And remember, you could plug 0 in and plug 1 in and into this right here to change your boundaries, but I'm just going to leave them the way they are. And I'm going to say ln, absolute value of 1 plus e to the x, evaluated from 0 to 1. On the next problem, I'll change the boundaries just to give you an example of what happens there. So let's see what we get here. ln, absolute value of 1 plus e to the first power, minus ln, absolute value of 1 plus e to the 0 power. Fit that all on there. So ln, absolute value of 1 plus e, minus ln, absolute value, 1, e to the 0 is 1, so that's absolute value of 2, which is not necessary. We don't need to have the absolute value there. But this will simplify. Okay, because we have a minus sign there, we can rewrite this as ln times the absolute value of 1 plus e divided by 2. And that is probably how you will see your answer written, because in that problem right there, they can test pre-calc and AP Calc in one problem. So that's just something to think about there. All right. So last problem here. I'm going to say u equals e to the x, because when I take the derivative, du is equal to e to the x dx, and I have an e to the x dx right here, so that's good. So integral from -1 to 0 of cosine u du. Take the integral, so the integral of cosine is negative sine of u. Now let's change these values. So if I plug in 0, e to the 0 is 1. What happens when I plug in -1? You get e to the -1. Okay, so I'm going to leave this in terms of sine u and just replace the interval with what I get by plugging the 0 and the 1 in here for e to the x. So I'm just switching it up there a little bit. So I have negative sine of 1 minus negative sine of e to the -1. A double negative there, so I'll change that. You could write this multiple different ways. Again, like I keep saying here, you're just going to check your multiple choice answers and see what answer matches the one you have. That's another way of writing it right there. So there's 2 examples for you. Okay, here's some homework problems. Go ahead and give those a try. And like always, if you have any questions, just let me know. And send me an email or a private comment or something, and I'll get back to you.